things sometimes. I miss them sometimes. Even math.
So you don't think you can get 100 on your own test?
I usually get 100 on my own test, yeah.
You take your own test always?
Yes, that's how I make the answer key. That's how I make the answer key.
Oh, I didn't know if you plugged it into a calculator.
No. I'm pretty confident.
Maybe a teacher, but you still have to
So let's talk about this lesson. Alright, so what you did was you looked through and you were looking for patterns. If it had an even degree, what did you notice? If the degree of the function was odd, what did you notice? Now, on this one, hopefully what you noticed, all the functions that were an even degree function, both the ends of the graph did the same thing. It either went up, or down, down. So if we were describing the end behavior, the ends would match, wouldn't they? Okay? The odd powered functions went opposite directions. One end went this way, the other one went the other way. They went different ways, okay? So these are the answers to K, and this might help you finish the packet tonight. Yeah, really. Yes, ma'am.
For H, what's the degree of the polynomial?
For H. I don't even know that I have that one opened. I'll come look at it and let you know in just a second, okay? Alright, this one. If we look at those individual factors, what did the factors tell us? Well, if the factor was raised to an even power, did you notice it was tangent, which means it bounced at that x-intercept? And if the factor was raised to an odd power, did you notice it passed through that x-intercept? Now, if the odd power happened to be greater than 1, did you notice it bounced through with like an inflection? Not bounced. It passed through with an inflection. It would go from concave up to concave down or vice versa. So there was, if this odd power was greater than 1, not only did it pass through, but it passed through that point with an inflection. It kind of had a wiggle right there at that point, didn't it? Okay. Do you see how these things are going to help us graph polynomial functions? If we know this about any function? Now, the positive leading coefficients versus negative leading coefficients. I divided it up into two categories, the leading coefficient and the degree of the function. So if the leading coefficient was positive and it was an even function, did you notice both ends went up? If the leading coefficient was positive and it was an even degree function, the end behavior of the function was to go towards positive infinity, both ends. But if that leading coefficient was negative, then both ends went towards negative infinity. Now, if the leading coefficient was positive but it was an odd degree function, then it was falling to the left and rising to the right. But if that leading coefficient was negative and it was an odd function, it was rising to the left and falling to the right. So I just made a little chart out of that. You could have said it in words. Did you notice that when you looked at the different functions? Maybe? Okay. How do we determine the y-intercept of a graph using its equation? Well, if it's in standard form, whatever the constant is the y-intercept, but most of these were in factored form. So to find that y-intercept, we have to plug in 0 for x and multiply the numbers that are left. So we can do that even without a graph at all. And then finally, how do we determine the x-intercepts? Well, the x-intercepts are those values of x that make each factor equal 0. Okay, so your homework is to finish up this packet. So you're going to think about these things. as you complete the rest of the problems. And we'll talk about them tomorrow. Easy?
I'd say nothing is
Then you're
really
gonna put in here.
There's just some stuff that isn't as.
Well, good.